Okay, I'll start with say part 2. Here are some questions. I'll take first question. As per the question, I'm reading the question, or I'll write the details of the question, whatever is given and whatever we are supposed to find out. So in the first question, it is about sensitivity of a galvanometer, and it is said that a galvanometer is to be refabricated so that its current sensitivity, I'll write delta S I. I'm writing SI as the current sensitivity that should change by 50%. 50% of 50% of SI. That should change by 50% of SI. That's the change in current sensitivity. Number two factor is given that when you are refabricating the galvanometer, it's found that resistance of wire which you were using is now two times the earlier resistance. So if earlier it was having resistance R, now after refabricating or redesigning, its resistance becomes 2R. Now in the question he asks, by what factor does its voltage sensitivity change? So we have to find out change in voltage sensitivity. Write S V. I'm writing here S as sensitivity. So we are supposed to find out this much. So this is our question, and now I'm going to answer this question. We have been given certain things and we are supposed to find out change in voltage sensitivity. Now before actually going into the question, I must know what is sensitivity, and although we have discussed earlier, so let me repeat that quickly. uh, we know that when a current carrying conductor or a coil is placed in the magnetic field, and if the magnetic field is radial, it experiences a torque, and that torque is equal to N I A B, actually sine of phi, but I'm not going to write that here because we are using radial field, and radial field sine of phi becomes 1, wherein the area vector of the coil and the magnetic field, they are perpendicular to each other. Now we know that there will be one more restoring torque. This is torque due to the current in the coil. In the restoring torque in the spring, that can be written as K into theta. This is the restoring torque. And at equilibrium, these two torques will be equal. So that means I'll write N I A B will be equal to K theta, where K is torsional constant of the phosphor bronze wire, or the spring constant of the spring that could be used in the galvanometer. Now we know that this expression could be written as theta upon I is equal to N A B upon K. Now this is what we call the sensitivity, current sensitivity, that is deflection per unit current, deflection per unit current, and we call it as current sensitivity. So this is what we are going to deal with, and what we are going to this is the term about which this question is asked. We are going to solve that. So we know that current sensitivity is NAB upon K into theta upon I. So I'll move on to next page with this information. So we know that as per the given question, it has been said that the current sensitivity changes. Let me write that current sensitivity by current sensitive change in current sensitivity SI, that will be equal to the new sensitivity SI. I'll write that dash minus the earlier sensitivity, that's SI. And as per the given question, that means we can write the current sensitivity, it is given by, that means the new sensitivity minus the earlier current sensitivity, that should change by 50%, 50 by 100 of the earlier current sensitivity. So that means this is given. This is given in the question. So that means I can write new sensitivity SI dash will be equal to SI dash into 1 plus 50 by 100. 1 plus 50 by 100, that is the new sensitivity, and I can simplify it somewhat. Upon simplification it becomes SI dash will be equal to SI into, this can be written as 3 by 2. So this is 51 2, that is 3 by 2. So that is new current sensitivity will be 3 by 2 of its previous sensitivity. Okay, I'll take one more expression because we know that जो sensitivity है, the sensitivity of the galvanometer, this is what we know. We know that sensitivity of a galvanometer SI is equal to N A B upon K. So that means while refabricating our galvanometer, we might have changed the number of terms, we might have changed the area, and of course the spring constant and magnetic field can't be changed because magnet is fixed there. So therefore I'll write the new spring constant, that will be equal to n dash, because we might have changed the number of turns, area that we might have changed, but magnetic field have not changed, and the spring is kept same. So therefore these things, there are two things that could be changed, and there are two things they remain constant. So therefore I'll put them into this equation. I'll put them into this equation that is marked as red. I'll put S1 and S2 into this equation. So I'll move on and put them into the value of, so therefore I'll write SI dash, that is N that is N dash A dash B upon K is equal to 3 by 2 into S dash, that is N A B upon K. So you can cancel out the common terms, say for a B and K, B and K. So therefore we got N dash A dash is equal to 3 by 2 NA. This is the relation between the new turns, new area, and the earlier turns and the earlier area. Now we want to find out, as per the question it is given that we want to find out what is the change in the voltage sensitivity. So I'll write that here, the change in voltage sensitivity. This is what we got so far. I would like to find out now change in voltage sensitivity, and we write that as delta V, that is change in voltage sensitivity. Sorry, I'll take this out from here. Voltage sensitivity, I'll write voltage sensitivity, that is SV V, that's equal to theta upon, theta means deflection, upon I into R. Voltage is equal to I into R. R is the resistance of the galvanometer, I is the current. So we want to find out SV. We want to find out actually change in SV as well. So therefore, I'll move on to next page. I want to find out the voltage sensitivity. So for voltage sensitivity, I'll do it this way. Voltage sensitivity, as we have seen, that it is theta upon, that means deflection upon I into R, or we can also write voltage sensitivity is equal to, because we know already this factor is known to us, we call it as volt current sensitivity. So therefore I'll write SI upon R, SI upon R. Now as per the question, we have got new sensitivity, new voltage sensitivity is equal to new current sensitivity upon the resistance if it is changed. So therefore I'll write new sensitivity will be equal to N dash A dash upon A dash B upon R dash into K. NAB by K into R dash, that is new voltage sensitivity. So therefore substituting for N dash A dash, which we have earlier derived, N dash A dash, N dash A dash we have derived here. So we'll substitute that into the equation. We'll substitute that into the equation to find out the new voltage sensitivity. So I'll write SV dash is equal to N dash A dash is 3 by 2 NA, 3 by 2 N A B upon K into new resistances 2 times R, 2 times the previous resistance. So therefore our new voltage sensitivity will be equal to 3 by 4 NAB upon KR, NAB upon KR, and we know that this factor is known to us. This factor is the voltage sensitivity. So therefore I'll write the new voltage sensitivity, the new voltage sensitivity will be equal to 3 by 4 times the previous sensitivity of the galvanometer. Now if you want to find out the change in resistivity, therefore change in resistivity will be equal to final resistivity minus the initial resistivity. So I'll write change in the voltage sensitivity, change in voltage sensitivity, I'll write that as delta, and this is delta S V, that will be equal to SV dash minus SV. So now it's not difficult to find out. I'll take it to the next page. So therefore you'll write the new voltage sensitivity, that is delta Alright, final result, that is delta V that's delta V SV delta SV is equal to, upon applying these, we can write delta SV is equal to, that is 1 minus 3, or that will be equal to SV, that will be 1 minus 3 by 4 upon 1. That comes out to be, say, that's 4 minus 1, that's 1 by 2 5, or that's roughly around delta Vs is equal to, say, 25%. So this is the new change in voltage resistance, 25%. That is a new change in the voltage, say, sensitivity. Now, say for example, there was a similar question that was asked. I'll write out whatever is the details of the question, and then we'll solve this. The question, in the question, it is given that, I'm writing here question again. To increase the voltage sensitivity of a galvanometer by 25%, we want to increase, that means we have got earlier sensitivity, we have got sensitivity of the galvanometer. Let me write it as S dash. This is your new question, so the voltage sensitivity is now known to us, that is NAB upon K. This is voltage current sensitivity, and in the question it is said that you want to increase by 25%. So delta SI, that is equal to 25% 25% of the previous sensitivity, that is SI. And in the question he has said that by doing this the resistance is changing, that means that the new resistance, that's equal to 1.5 times the previous resistance. For this factor we have to change the galvanometer in such a way that we are changing its turns, and by that the resistance is increasing, because we may be using more wire to have that sensitive galvanometer, current sensitive galvanometer, and therefore we are using 1.5 times the resistance, because by using more wire we are increasing the length of the wire or resistance of the wire. So how will the voltage sensitive be affected?